Hey guys, here's our notes we're going to take today about simple random samples. You can go ahead and put them on slide 23 through 26 of your digital notebook. At the top of your paper, you can put your title, just notes 1.2.2, simple random sampling. We're going to start off with some vocabulary. So our first one is just, what is a random sample? So a random sample is just a subset of a population. That was selected without bias. So what is bias or sampling bias? When you're picking your sample and there's bias, it just is errors in estimation caused by flawed or non-representative selection. So if I was trying to find the average height of students at Citrus Valley High School, and I go and I only do the people that are on the basketball team, they might be taller than some of the other people on our campus, so there would be some bias there. A simple random sample, that's what our notes is titled today, is simple random sample. Okay, so we want it to be random, no bias, and then we want it to be pretty simple the way that we are able to collect them. So it's just a randomly chosen sample where any combo of individuals from the population has an equal chance basically of being selected. So we have a few different ways that you can make a random sample. So ways to make a random sample. One way, a very popular way, is just a random number generator. This is just a tool. We can do it on our TI-84 calculators. You can Google one. There's apps, whatever it is. But it's just a tool. Used to select a number without following a pattern, and all probabilities are equal. So it's important that it doesn't follow a pattern. Every number should have an equal chance of being chosen. You can use a random number generator. It's not like you're randomly picking your favorite numbers. They're actually random. The next one is a deck of cards. You just assign a card to each person or object. Make sure you shuffle them, and then just draw however many you need. The last one is a coin flip. Your coin flip works when your chances of something happening are 50-50. Then you can use heads and tails to represent the two events. If you guys can hear that fly in my classroom, it is bugging me. Okay, so if probability is a 50-50 chance, a coin can represent the two events. You can just flip your coin. All right, so it's gonna be hard here because you guys actually can't see me, you just hear me. But we're gonna be doing some simple random sampling for our examples. Okay, so we're gonna go ahead and go to our example page in our workbook. This is on page 61. We're on Unit 1 of our workbook, page 61. So example 1, Mr. DeCenso wants to establish baseline measures for the 21 students in a psychology class on a memory test, but he doesn't have time to test all students. How could Mr. DeCenso use a standard deck of 52 cards to select a simple random sample of 10 students? The students in Mr. DeCenso's class are listed as follows. All right, so first what you would do is assign a value to each student. So there's 52 decks in the cards. There's only 21 students, so not every card is going to get used. You would just pull out the cards that you want. So I already, I'm going to go ahead and assign them. I pulled out certain cards. So we're going to do Tim. He's going to be the ace of hearts. Alex is going to be the 2 of hearts, 3 of hearts, and I'm just going to keep going until I run out of hearts. 4 of hearts, 5 of hearts, 6 of hearts, 7, 8, 9 of hearts. Then we have a 10 of hearts, and then it goes Jack of hearts, Queen of hearts, King of hearts. And now I ran out of hearts, so now I'm going to go ahead and go to diamonds. So Claire's going to be the ace of diamonds, 2 of diamonds, 3 of diamonds, 4 of diamonds, 5, 6, 7, and 8. And I already pulled these cards out. You guys can't see me, but in class, you'll be able to see me. So I went ahead, check, I assigned a card to each student. Now I'm just going to randomly select cards. So it's important that you shuffle them. So I don't know if you guys can hear me. I'm trying to shuffle my cards. I'm not shuffling them very good. They were kind of shuffled before. Okay, so I'm shuffling my cards, and then he wants to only test 10 students. So of the 21, he's just going to do a memory test on 10 of the students. So I'm just going to randomly select them, and then we'll see who it is we picked. All right, so my first one is the 5 of diamonds. So that means that Rafiq is going to be our first one. And then, let's see, I have the ace of hearts, so we're going to use Tim. I got the 8 of diamonds, so that's Gillian. I have the 4 of diamonds, so that's Laura. I have the 6 of hearts, so that's Morgan. I have the 5 of hearts, so that's Andy. So 1, 2, 3, 4, 5, 2, 4, 6, so I need 4 more. The 4 of hearts, that's Brian. Then I have the 7 of hearts, that's Victoria. Then I have the King of hearts, that's Quinn. And last one, the 9 of hearts, which is Ian. So I randomly selected my 10 people, I just assigned them a value, and then I randomly selected cards, and these are the people that I will get for my group. All right, let's go to example number 2. It says, Mrs. Tilton wants to estimate the number of words per page in a book she plans to have her class read. There are 373 pages in the book. Mrs. Tilton wants to base her estimate on a sample of 40 pages. Use a graphing calculator to select a simple random sample of 40 pages. We're going to go ahead and just use an online generator. And I don't want you guys to have to write down 40 different numbers. So we're just going to write down like how you would do it. We're not actually going to come up with our numbers, but you're just going to go to an online generator. Just Google random number generator. You do your minimum as the number 1. Maximum of 373, and then just generate 40 numbers. So I'm not going to make you guys actually generate 40 numbers and list all of those down. That would be a long time. All right, example 3 says the following table shows time it took in 100 trials to recharge a particular brand of cell phone after its battery ran out of charge. Each time is rounded to the nearest minute. Use a random integer generator to select 2 random samples of size 10 from the population of 100 cell phones. Determine the mean and standard deviation of each sample. Explain why the mean and standard deviation of the first sample is different from the mean and standard deviation of the second sample. So we have 100 numbers here. I don't know if my thing is connected to the internet. Yeah. Oh no, what happened? Okay. I tried to do it and it didn't work. Okay. So I'm just going to do it over here on my desktop. I'm just going to Google random number generator. I'm going to do my minimum as 1, my maximum of 100, and then I'm going to generate 10 numbers. My first number is 76, and I'm just going to highlight it. My first number is 76. Generate, I get 74. Generate, I get 56. Generate, 24. Generate, 5. Generate 39, 44, 12, 7, so I have 2, 4, 6, 8, 9, one more, 11, 2, 4, 5, 6, 7, 8, 9, 10. Okay, so then what we're going to do is we're going to go ahead and find the mean and standard deviation of these numbers right here. So we're going to use 71, 76, 81, 83, 72, 72, 75, 81, 72, and 74. So 71, 76, 81, 73, 72, 81, 75, 72, 72, 74. All right, so I'm just going to find my Desmos. We're just going to type in the word mean. This will give us the mean. I do some parentheses, and then I just type in my data, 71, comma, 76, comma, 81, comma, 73, 72, 81, 75, 72, 72, 74. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10. Okay, 74.7 is what we got for the mean. And then we'll just erase this and put standard deviation. STDEV. The standard deviation is 3.65. So back to our notes. So for this is our sample number 1. The mean was 74.7, and the standard deviation was 3.65. Now we're going to do it again. We're going to do another sample, same thing. We're going to kind of compare them. So I'm going to do 10 more numbers. So I got 84. I got 44, which I already did once. We're going to use it again. I got 47, 52. 47, already have, so I'm going to do a different one. 54, 69, 51, 2, 4, 2, 4, 6, 7, so I need 3 more. 50, 21, and number 1. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to go ahead and now I'm going to take these new numbers and I'm going to find the mean and standard deviation. So I have 70, 75, 67, 75, 84, 76, 69, 73, 74, and 68. Sorry, I got to keep like writing them down. 70, 75, 75, 67, 68, 73, 74, 69, 76, 68. And then we're just going to go to Desmos. And we're just going to type in mean, parentheses, and we'll just type in our numbers. So 70, 75, 75 again, 67, 68, 73, 74, 69, 76, 68. So my mean this time was 71.5. Then I'm just going to go ahead and get my standard deviation. This time is 3.439, so 3.44. All right, so for sample 2, the mean was 71.5 and the standard deviation was 3.44. So did we get the same exact numbers? No. So it says explain why the mean and standard deviation for the first sample are different from the mean and the standard deviation in the second sample. It's very unlikely that they will ever be the same. They should be close, but the reason why is we usually say chance variation. They're different by chance variation. They vary just by chance. That's what happens, is that we randomly selected them. They weren't exactly the same. If we used all of the numbers, that would be a better sample, but instead of we only used 10 from 100, so it's not exact. All right, we're just doing one last example, and then we're not going to do number 5. So example 4, it says the Bennett family believes that they have a special genetic makeup because there are 5 children in the family and all of them are girls. Perform a simulation of 10 families. We're not going to do 100. That's too many. Assume the probability that an individual child is 50%. Determine the percent of families in which all 5 children are girls. Decide whether having 5 girls in a family of 5 children is probable, somewhat unusual, or highly improbable. Okay, so what we're going to do is I'm going to do something with a 50-50 chance. So you guys can hear I have 5 pennies right here. So I'm going to do heads for girls. And I'm going to do tails for boys. So what we're going to do is I'm going to perform my simulation, and I'm just going to say in the family of 5 children, because I have 5 pennies, so each of them represents 1 child. We want to know, we're looking at how many of them are girls, right? We want to know the probability, the chances of families that will have all 5 girls, and if that is probable, somewhat unusual, or highly improbable. So I'm just going to write down how many girls are in each family. So my girls is my number of heads. So I'm just taking my pennies. My first one, I have 1, 2, 3, 4 girls. So I have 4 girls in my first family. I'll do it again. I have to do it 10 times. My next family has 2 girls. Next family has 3 girls. My next family has 2 girls. My next family has 4 girls. My next family has 2 girls. My next family has just 1 girl. I have just 1 girl again. I have 1, 2, 3, 4, 5, 6, 7, 8 families so far. So I need 2 more families. I have 1 girl. And last one also just has 1 girl. Okay, so what we want to look at is we want to see how many of our families, we only did 10 instead of 100, but we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 families. How many of those families had all 5 of them girls? 0 out of 10 of them. So some class periods we might get, some that actually are all 5 girls, but we had a 0% chance. Does that mean that it never happens? No, it definitely happens. There are families that have 5 girls, but it is highly improbable. So It does not mean that there's a 0% chance that it could happen. It can happen. It's just highly improbable. Okay? All right, that's it. We're not going to do example 5. Your practice is in your workbook on page 67.